Alrighty everyone, welcome to day 5 of Adventico 2022. A few seconds here and we'll get into the problem for today. I'm raising my camera's a little off, but anyways, can't fix it now. On to day 5 problem. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. You do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, your puzzle input. For example, this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Stack 1 contains two crates. Crate Z is at the bottom and crate N is at the top. Okay, so forth, yeah. Then the rearrangement procedure is given. Each step of the procedure, the quantity of the crates is moved from one stack, different stack, resulting in this. Okay, it makes sense. Move 1 from 2 to 1, move 3 from 1 to 3. Wait, what? In each step, the procedure, a quality of crates is moved from one stack to a different stack. In the first step, okay, in the second step, 3 crates are moved from stack 1 to stack 3. Crates are moved at 1 at a time. Okay, gotcha. Makes sense. The elves needed to know which crate will end up at the top of the stack. After the rearrangement procedure completes, what crate ends up at the top of each stack? Oh my goodness, we gotta like, how am I in? Okay, the parsing in this one's gonna be a pain, because I gotta parse this. Okay, well, day 5. Let's do this, I guess. Wow. Okay, so let's one space. Okay. And then I'm like trying to think of 3. Okay. All right, we're gonna first do these lines. So the first 8 lines. So for int I equals 0, while I is less than 8, I plus plus. Actually, screw that. We're just gonna do a sub list here. This is going to be the stacks, and this is going to be input sublist 0 to 8. It's probably exclusive, right? Empty, exclusive, yeah, okay. So we have our stacks, so now we can do string s and stacks. The issue is that these are top to bottom, which is reverse of what we want. Although I guess we can do it either way, it's fine. I should probably do these 0, so that's fine. Okay. So I'm not gonna do a list. We're gonna do a list of lists. I'm gonna make these strings. So this is actually gonna be stacks. I spell stacks right, and this is going to be stacks input. Okay, so for each one here, so what we're gonna do is we're gonna first test. Well, these are gonna be 3 character batches or 4 character batches. 1, 2, 3. I want to split on spaces, but because of these, I don't want to do that. So I want to split every 3. Well, 1, 2, 3, 4 technically. So here's what we're going to do. We're going to do string. This is going to be line. I don't need to worry about that. We're going to do int index equals 0. We're going to do a while index is less than s dots length. Okay. So what we're going to do here is we're going to each step is going to test if s.char at index equals a space, then we can skip over it. So I guess if it does not equal space, that's what we want to keep. So this is our index, but we're actually going to want... Now that's fine, because we can do index times 4. Yeah, we'll get away with that. Cool, and then we're just going to increment index. So this is actually always going to be index times 4. Ignore the times 4. Times 4 is just to make this a little bit easier. So if it's not a space, that means we want to the next... I'm going to do this because I'm lazy a bit. Okay, we're going to do this. String index, string index, string index plus equals 4. I could do math on these, but I'm just not going to worry about it. I have 2 variables. So string index 2, so if it's not a space, we want to go to the next one because that's the one that's actually going to have the character we want. So we're going to do s.char at string index 2. It's capital for no apparent reason. Plus 1. So this is our character, and then we're going to actually implement this into the stack. So the stacks are actually become chars instead of strings. And so what we're going to do is we go stacks. Arrays, list, new lists. We got to do some new lists here. That way it a new array list. Hello. That way they're sort of predefined in here. So how many stacks do we have? We have 9. Okay, this is the dumb way to do it, but you know what? I'm gonna do an array. Never mind. Ignore me. We're just gonna do an array, and we're gonna pre-populate it. I is less than 9. I plus plus. Stacks. Stacks. Add new array list. There you go. Pre-populated, so now we can do stacks.get index. And I guess we're just gonna add, but we're always gonna add to 0. And we're gonna add this char at. So that should, in theory, populate these just fine. Increment by 4. Which is 1, 2, 3, 4, which gets us to this. Beautiful. So now those should be correctly populated. Can you give me just 0? Just give me 0. Stacks.get 0. If I run this, do I get the correct WRF? WRF. Hey, we actually correctly parsed it. All right. Hard part should be over in theory. Now we go to the easier bits. So now, this is going to be instructions. And this is going to be a sublist from 10 on. 10 to input dot size. Okay, and then we're going to go for each instruction. So this is going to be I in instructions. We're going to have to parse out the instructions. So let's split on spaces. So go ahead, split on spaces. That should be all we need. And we don't care about move. They always say move first. So we just care about the amount. So this is going to be, oops. Int toMove is going to be equal to parts 1 and parse integer, or integer parse int it. Parse int. Okay. And then the next 2, so again, skip 1, skip 1. Okay, so it's going to be 1, 3, 5, and it's toMove, and then it's from into. Cool. And using this now, what we can do is we can go ahead and just do move from the top. The top is the end. So we're going to need a list. This is going to be of characters. This is moving. And we're going to do for int I equals 0 while I is less than to move. I plus plus. Can't use I because it's already up there. So this is J. And we're going to go ahead and do moving, add stacks get from actually, let's go ahead and just make this a little bit easier. Let's do list character from stack. So add from stack, remove from index from stack dot size. Just remove last. Oh, size minus 1. Always remove the last one because that's the top. So that's then all added to moving. And then now we just need to go for each one in moving. So we're pulling off from the top and putting it in. Which is right because we want to move it from 0. Okay, so that's fine. So now we can do character C in moving and simply just do the 2 stack. And just do 2 stack add C. Because it's going from 0, whatever, that'll be fine. I guess we can just do an add all. Cool, and so that should then be the end, and all we need to do is just get the ones that are top. Is that what's asking, right? Just what's the top? Yeah, so now for, oops, not outside here. String builder, 'cause why not? String builder is gonna complain if I don't. String builder, come on. Now we're just gonna do for list of characters in, this is gonna be the stack in stacks, and just do string builder append stack get stack dot size. Size, come on. Size minus 1. And then we can just call lap on str to string. And in theory, if I did this all right, we should get a string. Index out of bounds. Subtract 1 from all these, right? Because indexes are fun. Start at 0, not at 1. Not human readable. Got rank 9. I got top 1,000. That's not too shabby. This year's kind of all whack because of the GPT-3 stuff, but I'll take top 1,000. Part 2. As you watch the crane operator expertly arrange the crates, you notice that the list isn't following your predictions. Some mud was covering the writing on the side of the crane. It's crane mover 9001, okay? Ability to pick up and move multiple crates at once. Okay. So if it picks up one, okay, so all that happens now is, so for part 2, we just need to make a copy of our stacks after this. So, equals stacks dot, is there a copy? It's not like a copy. This is the easiest way to do this. Copy, add, and then copy, get, I, add all. Actually, we can just do this, screw it. List, characters, char copy, new array list. Then we can just do char copy dot add all from stacks dot get I, and then go ahead and add that in. Oh, that works too. I know Java. All right, so now we have copy. So now as we go through these instructions, we can also edit on the copy one. So we can still reuse this, but what we'll do is, this is gonna be part 2 down here. So what changes is that we can no longer do this little moving trick. Well, we can. What we need to do is we need to always add it to 0 because 0 is our bottom. And so if we do that correctly, now we can just do, well, I can do this because the to stack and from stack are now from copy instead of stacks. And now we should be good to then do this on instead of stacks, do it on copy. Fingers crossed I do this correctly. Hey, look at that. Not bad, not bad. Oops, I meant to do the stats. I'll take a top 1,000. Not too bad for today. I know this, again, this can be kind of all warped, and of course me using Java is kind of throwing this all out the window because, again, Java is not exactly the fastest language to write solutions in, but I'm happy with today. I'm happy with how quickly I was able to figure out how to parse this. I'm sure there's probably some more elegant way to do it, but yes, I keep doing that. I am overall happy. So I don't think there's gonna be anything I can clean up from this. I think this is, honestly, for the way I did it, this is about as clean as it's gonna get. So shall we explain how today's works? So for today's puzzle, we are given basically, the puzzle goes that you have elves and these crates are in some sort of stacks, and there's a crane that is moving the crates between the stacks in order to get certain ones at the top. And for parts, well, for part 1, the crane works one way, part 2 works the other way. So I'm gonna do these kind of all in one go here and explain the differences as I get to them. So the first thing we have to do is we have to parse in this this input here. This is kind of two parts of the input. The first part is the initial state of our stacks, and the second part is the instructions on how the crates are actually moving between the stacks. For parsing in the inputs, don't get overwhelmed by it. It's not too difficult. You have to understand that this is actually structured in a very structured way. It's in a very predictable way and a very easy way to parse in, because you'll notice that each stack here is taking up basically 4 characters of width, whether it be 4 spaces or a space and then the brackets and then the letter goes with. It's in a very structured and organized way. Because of that, what we can do is we can go through each line. We'll start here at this top left of this. We'll parse in this first line here. What we'll do is we will first check the initial character we're at. Because the first line will begin with a space, if there is nothing there, we can simply ignore the spaces. And if it doesn't actually begin the space, basically if it's really anything else, we could make it just check for the square bracket. But if we'll make it easier, we'll check for not a space. In this case, there is a space. So if there is a space, all we do is we ignore this and we simply increment our index. This is just to know what stack number we're in for the index of that. It's not really needed because you can derive either one of these. I did 2 variables. You don't have to, because again, given one, you can derive the other, but it's easier for this just to do it both, for at least for me. So the index will increment 1, but then our index in the line will increment by 4, because if we go by 4, 1, 2, 3, 4, you'll notice that our next letter up is this column here, which is the very start of the next stack. In this case, we read this one. It is not a space, so we'll go ahead and do the next step, which is to then take the index we are at in the line, which in this case is on this character here, add 1 to it. So now we're on the P character here. Grab that character out, put it into our stacks, being careful to put it at 0, because again, these stacks, the bottom of the stack is index 0 with index going up. So this is 0, 1, 2, 3, 4, so on and so forth. So we always add to our stacks at 0. That way it's always placing it at the bottom. Everything else gets shifted up. And then we continue on, again, incrementing our index. We're at the next stack position. And then adding 4 to our string position. That we are at the next column and the string there. And we are ready to read in, see if it's a space. Continue on. If it's not a space, again, read the character on, so forth, so on and so forth. And that is how you parse this entire thing. Don't get overwhelmed. It's honestly not too bad. Just find the pattern, find the structure, and you're golden on this. So now that we have correctly parsed in this entire stack, we are on to the second half, which is the instructions. Luckily, again, it's just like above, these instructions are very structured and we can easily parse this. We can simply say just split on the spaces, make one into our parts here. So this is one index, next part, next part, next part, next part, and next parts. And then from that, we can now take out the actual information we care about, which is going to be the first index, the third index, and the fifth index. The first index here being how many of the crates we need to move from the stack. The second, or the third index, the second piece of information we care about, is the stack we need to take from, in this case 4. So we're taking from this stack. And then the number that we're moving it to, which is 9, which is this stack. So after splitting up on spaces, we can now parse out the how many to move, parse out the index we were going to, and then, the index we're going from, and then the index of the stack we're going to. Again, subtract 1 out because they start counting at 1. Java starts counting at 0, so that's why I got subtract by 1 here. And then from that, we can get the stack we're taking from. We can now get the stack we're going to. And then we can go about actually moving them. This is where they will differ a bit. For part 1, the crane can only move one crate at a time, or one letter at a time. And because this, what you can do is we can just go through how many to move, take from the stack at the end, because again, we're taking from the top and then adding it to the array that we're moving. And then from that, we can then just add them all to the new stack, because again, if we take out one by one, this will be index, let's go to this one. So this is 2 from 4. This is the first one we take out, so this is index 0, this is index 1. And then because of how our array is structured, this is 0 and 1, if we're going to iterate back through it, so it's going to go R, then H, and we're adding to 9, so it's going to say R, add R first, so R will go here, and then add H will go right above it here. So because it's added in that order, they will come out in that order and then be correctly added to our new stack correctly. So that's why it's not too bad. That's why we can just go ahead and remove and then add all. The second part, though, the crane actually moves them all in one go. So it's going to move R and H together, which makes H be the first one added and R be on the top. Because of that, then we need to do basically the trick we used above, up here, where we add always to index 0 here. That way we keep the ordering correctly, and that makes it so that way we can just again do a move all, but keeping the correct ordering for how they should be. So that way add R to 0, but then add H to 0, that pushes R to 1. So now when we add H to 9, H will go first and then R, and that's how this works. And then after that, that is actually it. It's just a matter of going through all the stacks, taking the crate that's at the top, which is at the end of the index of the list, and then adding to a long string, outputting it, and there's our answer. So that is day 5 complete. If you can just get beyond the parsing, don't let that scare you. It's not too bad. The rest of the problem is not hard. It's just getting that initial parsing done. So anyways, hope you guys enjoyed. Thank you guys for watching today. I'll see you guys all tomorrow for day 6. Peace out.